In this lesson we're going to take a look at answering application questions of circular functions. That's right, everybody's favourite, where we take the skills that we've learnt and apply them to the worded extended response questions. So example 1, we have a cosine function and a little short story about Logan, who's a really nervous traveller on a flight from Melbourne to Darwin. His anxiety level is modelled by this particular rule, and we're told that A is the level of Logan's anxiety in whatever units that might be, and T is the number of minutes after takeoff. In every extended response question there's usually a couple of marks that would be the easy marks, and part A here is just the straightforward period and amplitude of the function. So we know from everything we've done in the past that amplitude is the number in front of the sine or cos function. So in this case it's 35, and the period as given by the rule 2 pi over n, where n is the number or value in front of the angle. So in this question it's 2 pi divided by pi over 120. And a reminder again, when we divide by a fraction we multiply by its reciprocal, so that ends up being 240 minutes. So a couple of easy marks there. Part B is asking us for the times when Logan's anxiety level is at a minimum. So there's a couple of ways you could do this. You could work algebraically, or you can hop onto your calculator and use the graph and find the minimum point on the graph window. We're going to do it both ways in this example. So first, algebraically, we know any cosine function has a minimum and a maximum of 1 and negative 1. So what you could be doing is you're saying, when does this function here have its minimum point? So in other words, when is cos of the angle equal to 1 or negative 1? So using our little unit circle, we know that this point over here has got a coordinate of negative 1, 0, and this point over here has got a coordinate of 1, 0. So it's either going to be 0 or pi. So we want to make this angle over here 0 or pi. So what values of t is going to give us that? So what we're working out is pi over 120, t minus 20. When does that equal pi, and when does that equal 0? So when you solve that, we end up t equals 140 or t equals 20. That's algebraically thinking about your minimum and maximum of your cosine function, or as I said, you could hop onto your calculator and use the graph to help you solve that question. Just before we hop onto our calculator, you can see here that part C we're going to be sketching the graph. So usually with any extended response question, when there's 3, 4, 5 different parts to it, my advice would be that we actually define the function on our calculator before we go ahead and answer all the different parts. Just keep in mind though that in your graphing window of your calculator, it only graphs functions using the variable x. So in this particular case we have a of t. When we define it, we need to replace that t with an x, just so that the calculator understands it, so that it can actually graph it in the graphing window. So let's hop onto our calculators. So the first thing we're going to do is actually define that function. So menu, actions, define, and then type in the rule. A of x, remember, not t, is equal to 45 minus 35 cos. You might be a little bit quicker on your calculator. Pi divided by 120 and x minus 20. Press enter and it's telling you that it's done. Just another piece of advice though, I've defined that function, but in the question itself, if you have a quick look, in the question itself, we're actually given a domain. So when you're defining a function, if you know what that domain is, then at this particular point here, you can enter that domain as well. So given that 0 is less than or equal to x is less than or equal to 240. So now that you've entered that domain, that function is fully defined. So to sketch that graph, if I insert a graph page, down here in the entry line, I don't need to type in the rule. I can just simply type in a of x and it will draw the graph for me, as you can see. But as you can see, there is no graph. So that means we need to adjust our window on the axes, which we find that in menu. So because in window, because we know the domain, we can enter in there minimum for x is 0 through to 240. Okay, and I still can't quite see the graph. So if I go window and zoom fit, there's my graph fully drawn within the domain. You can see 240 down here. We also need to find the other key features like the y-intercept, this maximum point, and the endpoint. Now, seeing as I'm in my graphing window already, one way of finding that y-intercept would be to use the trace function, graph trace. And if you just simply type in 0, you can see down the bottom here x equals 0 because that's where a y-intercept occurs. Press enter and it moves the cursor to that point and it tells you the coordinate down here. So you would know that your y-intercept would be 14.689. The maximum point up here, like we did with the minimum, so menu, analyze graph, maximum, lower bound and upper bound. There's your maximum point there, 140 with a maximum of 80. The endpoint at 240, again you could do trace graph, type in 240 and it would take the cursor to that point and you would see that it's also 14.689. The problem here is that if by chance the question wasn't asking for decimal places and you needed to give an exact value, you're not getting that in this graphing window. So if you go back to your calculator page, because we've defined the function, it's really easy to find those points. The y-intercept we know happens at x equals 0, so all we're doing is finding a of 0. Press enter and there it is there in exact form, and control enter just to show you that that's the same value as what we found on the graph. The endpoint at 240, we're just finding a of 240. Press enter and again it gives it to you in exact form. So although the graphing window is useful, if you need exact values, then on your calculator page is where you're going to find those. And then you just need to transfer all this key information from your graph onto the grid that's provided for you on the paper. Now the question has one last part, and that's part D, which is saying Logan needs a chamomile tea to calm him down when his anxiety level rises above 65, and you need to find what time he needs to start drinking this tea. So on your graph, the easiest thing to do would be to draw your line y equals 65. There it is, just in your entry line. Type in 65 and you get your line. So what's happening is that he takes off on the aeroplane, his flight begins here, and he's okay, and at this point over here is where his anxiety level reaches 65. So you need to find that point there. That's when he needs to take his tea to calm his nerves down, because in this stage of his flight he's going to be way too anxious. So menu, analyze graph, intersection point. We want this point here So again, there it is there. So the time is 103.23 minutes into the flight is when his anxiety level is going to be 65 or more. So then you would go back to the question and you would then answer that according to the appropriate units. When you find it, there it is. So we had an answer of 103.23 minutes. So you could answer now. In an exam, they would probably say to the nearest decimal place or to the nearest minute, so you would have to do what the question says. This you could say is 1 hour and 43 minutes into the flight, or if it said nothing, that would actually get you the mark. So hopefully you've understood example 1 and are ready to progress to example 2, which will be the next little screencast video. So good luck.